Hello and welcome to TidyX episode 151, TidyX screencast where we go through and explain how our code works. My name's Ellis Hughes.
My name's Patrick Ward. Thanks for checking in with us at TidyX. We always appreciate you being here with us. Today, we are continuing on with our Shiny model building user interface app. Um, as always, like and subscribe on that YouTube channel. This is the fourth episode in this series. If you want to see more, if you want to see us add other things to a sort of Shiny UI like this, let us know in the comments section. That's the best way to get in touch with us. As always, we have a Patreon page. We're super appreciative of anything you'd like to donate if you feel like we've in some way impacted your work. That said, episode 151, you can see on the screen, Ellis has it pulled up, and what we've added today is the option for the user to select multiple different types of models with those cool little radio buttons. So we're going to take you through how to select a different model and what the user interface does. Ellis, why don't you kind of give us a look at how the user interface behaves, and then we'll go through the server.
Let's do it. All right, so I've uploaded empty cars. I'm going to select cylinders as the outcome variable here. And I'm just going to add a couple of those predictor variables. Last week, we showed you how to set it up so that you don't accidentally select your outcome variable as one of your predictor variables. That was a lot of fun. If you haven't seen that, definitely go check it out. And we also showed you in episode 149 how to do the test and training splits. Now we're going to do the type of models. A lot of you have requested, hey, we'd love it if you were to add more models than that simple linear regression. And we've heard you, and now we're answering it. So we came up with some tree-based methods that we're going to go through this episode. Again, if you want to see more, if you want to see different types of models, more complicated models, and how we might approach that, leave a comment down below and let us know. So we're going to now click on random forest here. It's just a radio button, so you can click only one at a time of those three. And now it's changed from using an LM to using random forest. And now we can see we printed out some summary there of the random forest call, kind of the high level summary statistics of the squared residuals and the percent of variance, the split here, as well as the predictive values. I think cylinder might not be the best thing here. I'm going to switch back to MPG, see how it removed all our predictor variables. So we're using the first version of our protection there. But yeah, so we can see how it's changed the predictions and the residuals here in the histogram, as well as the predicted values versus the actual values, so you can kind of get an idea of performance. Then we can go to decision tree, which is obviously a simplified random forest, or random forest is a more complicated decision tree, I guess, depending on how you want to look at it. But here we've got the summary of the decision tree and the cuts that it's making. We've got, the residuals and the out of sample predictions. But we also are, because it's a single tree, are able to print out or make a plot of the tree that got generated based on this data set. And so it's split on weight, 239.25 tons. So if you have less than that, you're likely to be having an MPG at 29.1. And then if you're greater than that, then it again splits on weight. So basically weight does a lot of the decision making here. But then of course, if you have a quarter second that's less than 17, you're going to have a 15.88 MPG versus a 13.6. But anyway, so this is kind of the UI, but let's dive into how the actual Shiny app works. So I'm going to stop that from running, and we're going to talk about the code. So as usual, we've got all our library calls at the very top here, from Tidyverse, Shiny, DT, Shiny widgets, and then the two new libraries of the model libraries that we're calling Random Forest and Tree. We do our theming so that our ggplots look real nice. And most of this, first we're going to talk about the UI. Patrick, do you want to take us through the UI?
Literally everything in the UI is pretty much the same from episodes 148 to 150. The only thing that's changed is in the sidebar panel, I've gone ahead and added this radio buttons option. And so similar to the other calls above it, this is just a radio buttons function. It's telling It's telling Shiny that we want those little radio buttons. The input ID that we're going to be able to use to call down below when we want to find the model that we're looking for is going to be model. We're going to label it as what type of model with the semicolons or with a colon, so that we're telling the user, hey, pick one of these. And the choices that we're providing for them are going to be linear regression, random forest, and decision tree. I didn't name these explicitly because I want the user to see exactly what is there. But if you had a different name, like if you wanted to name it just regression instead of linear regression, you could name it whatever. Yeah, exactly. Abbreviate them, DT, something. Yeah, there you go.
We don't
And
want to
that'll
do
work
T since
just the same.
that's a package, but
Oh, yeah, that's true. So yeah. So, and what they would see now would be LM, RF, and DEC underscore tree instead of those specific choices. So either way, totally, totally fine. I just named them explicitly. After that, the main panel doesn't, the only change to the main panel is that I've added in tree PLT. So if in the event that the user selects a decision tree, we're going to go ahead and plot that out, which we saw in the user interface. The other two models don't have a cool looking plot like that, so they get nothing. And we'll show you how to do that in the server, which we'll go down to right now because most of this UI we've talked about.
yep. Let's send it. All right, now with the server, again, a server is a function. The UI is more the result of a function. So in the server, we've got input, output, and session. We've covered this substantially in the last several episodes, so we're not going to jump into this too much, but this is how the data gets uploaded. This is where it observes and updates both the outcome variable decisions as well as the predictor variable decisions. Again, jumping over this, we covered this in episode 150. Then we do our training and test splits here. This is in episode 149, so we're not going to go into that. What's interesting now is when we actually generate our fits, because before we were just doing a very simple LM, throw it into the LM function, we're done. We don't got to think about that anymore. Now we've got to be able to have this reactive change based on the model that was selected by our user. And so there's a couple different ways we can do this. I set it up one way, and then in the commented code, Patrick wrote another way. So we're going to cover both of those. So the way that I like to approach this is, okay, so I guess we should do a little bit of setup here. So we're requiring there to be a model selected for us to run the model. I mean, I think that stands to reason. So we're requiring input model. It goes and pulls the input data set. It selects the input yvar, so the outcome variable, and changes that name to dependent variable, and keeps the rest of the predictor variables, and slices to keep all the training IDs. What I do here is I create a list, and lists can contain basically any other objects in every entry. So what I do is I make a named list. So it's got 3 different entries matching the names of the model type they could select. So linear regression, random forest, and decision tree. Because there's spaces, I have to put these backticks around it to make it so that list will recognize it as a viable name. Now the entries that I put in there are functions. So I put in the LM function into the entry for linear regression. I put the random forest function in for random forest. And then for tree's a little bit more complicated because we want basically the input when we call those functions to behave the same. But tree required us to specify the split. And so I do this by wrapping it inside of another function. And I say, hey, this function is going to call tree. I'm going to pass any arguments from this using this triple dot notation. But I'm going to specify that we're going to be using the split deviance when we call tree. And so now when it calls input model, it's going to call either the LM, random forest, or tree, pass in the formula as well as the data for us, and fit the model right then. Use it calling the fit func entry in that list entry and assigning it out to fit. So that's kind of a roundabout way. The reason I like to set up lists like this is because it allows me to build it out very easily and without having to do a bunch of if-else statements or changing that. And I can almost hard code, quote unquote, my logic if I need to apply some special sauce to how the function gets called, I'm able to call it inside of this function. All right, so I'm going to comment this out and let Patrick talk to how he approached it.
Yeah, so if we were going to take the if-else approach here, we have three options. So we're basically going to check to see which input model that the user specified. So in the case of them selecting a linear regression, within the curly braces of that first if statement, we're going to store a model called fit, and it's a linear model. Else, so if they called something other than linear regression, it's going to check the conditions, and it's going to say, else if they called random forest, let's go ahead and fit a random forest model. And then finally, if it hasn't been linear regression or random forest, else it's going to check if they actually pick decision tree, and it's going to go ahead and fit that decision tree model. So either way, we're going to get to the exact same result. It's just how you like to code this. They both are about 6 lines of code. The one above it is probably a little bit cleaner and easier to read. I mean, reading 3 isn't so bad, but I've definitely had if-else statements that can be crazy long, and it kind of goes forever. So yeah,
It keeps on growing. So
yeah. So it really just depends on what you're doing and how you want to approach the problem, and kind of how many of those if-else statements you're gonna need. So either
how far
way,
you
though,
got to
you're
build
gonna
it
get to
out.
the same. Yeah, you're gonna get to the same result here, which is fine.
Yeah, and then fit gets returned and assigned because we love using the same names because we want to confuse you. It gets assigned back to the fit reactive. So let's put that down here. So next we go into the output. So this has been all the setup, right, for the Shiny app to set up the data sets to fit the model. But now we want to present the results of our fit model to our users. And so we have done this before. We using the render print, and we would call summary on our fit reactive to get the summary of our linear regression. However, while summary does exist for decision trees and random forest, when you call it, it isn't as informative as the summary call on, at least in our opinion, on the linear model fit object. So rather than calling summary across any model, no matter what, we added an if else. We left it as an if else because it's there's only one situation that we're calling out as special, and the rest are going to be defaulting to just printing out the result of the fit. And so this is the way that you go about this. You have the render print. We have the if the model is a linear regression, call summary on the fit. Otherwise, just print out the fit. And there you go. That's kind of an easy way to toggle between the model fits here. Patrick, do you want to take us through the rest here?
Yep. So this next little bit here is exactly the same as we had in the previous episodes. We're just going to make a prediction on the test data set. The predict function is a really useful function in R because it basically houses a way of making predictions from all of these model types. So nothing to change there. The one thing that I did change here in line 191 is in the previous episodes, because we were just using a linear model, I just used fit $resid and got the residuals out, and we use those for the out of sample plots and histograms and things like that. With the decision tree and the random forest model, or other models, that resid function or calling the name of the object and then $resid, either way, it doesn't produce anything or it kicks out an error. So for here, I just explicitly calculated the residuals, which is the observed value from the test set, the observed dependent variable minus the prediction. I just went ahead and calculated those out so that they're explicit. And even if we were just doing the linear model, this is probably good practice because it makes it very explicit, and we know that downstream we can always call those residuals for other things versus always having to call the model and then the residuals themselves. After that, we get into our out of sample plots. This is exactly like we had before. So we're requiring an input data set. We're going to now just calculate the mean absolute error on our resids reactive. because we, remember, calculated that just above. And we're going to also call the histogram on the resids reactive. And so this is all just the normal stuff of the residual plot. And then down below this, the predicted plot, where we're making our predictions. Those are, again, a reactive. So we have to give them the braces there, or the parentheses there. But this is all the same stuff that we've done. The only addition that we've added is that if the person happened to call decision tree, we're going to go ahead and we're going to plot that out. So we're going to plot the fit of the decision tree and then the text, because otherwise you just get the lines. So we want to make sure that it's somewhat interpretable and they can read what's there. And this is just a single if statement. So you notice there is no else. This is literally just saying, hey, if they called input model decision tree, plot it. Otherwise, leave it blank, do nothing. So there's nothing there to see, nothing to see here and move along. After that, these are just our DT tables of the train and test split. So we're just extracting out those data that we select from the train and test split, and we're letting the user be able to kind of query that data for a sanity check purpose later on if they need to look at it. That's it for the Shiny app. We can run everything here and actually get the result returned back to us. And there it is. And we select our data.
Let's actually change this. Let's use the batting data
baseball,
set. Let's make this a
yeah,
little bit more interesting.
so let's do like maybe like
home runs.
Home runs, yeah, okay. And
Let's
probably
see.
something like at bats and maybe runs. So it's like maybe hits, yeah, something like that.
Yeah, let's leave it there.
Yeah, okay. So we have three variables. We have a 3-variable model. It's just a linear regression. We get the result at the top. We can see that there's no decision tree. There's nothing below those two residual plots. So now if we go to random forest, we're going to get a little bit of a different prediction.
It's got to run through. This data is a little bit larger
There
than empty cars.
And we can see that we get a little bit of a different model output at the top. Here we're seeing the mean of the squared residuals, as well as the R squared, or the percent of variance explained between the observed and the predicted values. And again, we have the option of changing the amount of data we want to allocate to our training set. So we could drop that down and do a 50-50 split if we wanted. And so now it's just going to kick out predictions on 50% of the data. And then the final option is the decision tree. And at the top, we'll actually see the tree written out in kind of a text format. Below that, we see our plots. Obviously, decision trees do kind of weird things with predictions, so we can see the data there looks almost discrete. And if we scroll down below now, because we selected decision tree, we get a cool little decision tree here. So here it's saying, if we're trying to predict home runs, starting with runs, if you had less than 61, basically 62 runs, go to the left, and then it splits on runs again, and it tries to estimate your home run count. If you had more than 62 total runs, you go to the right. And again, it's basically runs looks like, if in this decision tree, runs looks like the value that is really only meaningful to split on for this decision tree, at least, which is why the predicted values in the plot on the upper right look the way they do. It's really only splitting on that single variable.
It's very discrete.
If we added other variables, yeah, if we added other variables, we would probably have some sort of different types of information, Yeah. So starts to.
There we go. So RBIs.
Now RBIs is important. Obviously, a home run is an RBI. It's a run batting. So,
it's almost like it's predicting the same thing or something.
Yeah, exactly.
Maybe knowing your data is an important thing.
Right. As if. But yeah, so that's basically the nuts and bolts of the of this Shiny app. If you want other ideas on how to progress a Shiny app that allows the user to build models, if there's other things you'd like to see, maybe ideas that you have for it, drop them in the comments below, and we'd love to try and field those and make them into a new episode.
Yeah. No, we always love hearing back from our viewers and hearing the ways that it's helped you, hearing the things that you'd like to see next. It's really inspiring for us. And with that, we're calling episode 151. Thank you for joining us. As always, my name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick, at tidy_explained is where we both are on Twitter simultaneously. Tidy.explained@gmail.com is where you could email us. But again, as we've said through the episode, the best way to hit us up is that YouTube channel. Like and subscribe down below. Tell your friends. If there's other things you'd like to see, different types of series, things that you're having problems with, hit us up. Let us know how we can be of help and build it into an episode and help others. As always, if you appreciate the work we're doing and you'd like to donate to the show, we do have a Patreon page. The link is down below, the YouTube channel in the comments.
Thank you all so much, and keep on exploring your world.